Very good morning to all. I, Shashank, welcome all the participants for the webinar on Fundamentals of Industrial Robotics, Robotics Workcell Design, Session 3, which is organized by Sanatana Research and Training Institute, a unit of Sanatana Sampradishthana, Mysuru, in association with Rotary Club of Mysore West. Prayer is the process of talking to God in order to achieve a purpose. So let us begin this webinar by seeking the blessing of Lord Almighty. Vakratunda Mahakaya Koti Surya Samaprabha Nirvignam Kurume Deva Nirvignam Kurume Deva Sarvakaryeshu Sarvada. Now I request Dr. Ramachandra CG, the Managing Trustee of Sanatana Research and Training Institute, to welcome and introduce the speaker of today's webinar. I also request him to welcome the guests and the participants.
A very good morning, one and all. So I take this opportunity on behalf of Sanatana Research and Training Institute, which is an unit of Sanatana Sampradishthana, Mysuru, to welcome today's speaker, Dr. P. Sivasankaran, Associate Professor, Manakula Vinayagar Institute of Technology, Pondicherry, and officials from Rotary Club of Mysore West, Mysuru, participants from different parts of the country. So let us begin with the introduction for today's speaker. Dr. P. Sivasankaran has obtained BE degree in Mechanical Engineering from Pallavan College of Engineering, Kanchipuram, and ME in Industrial Engineering from Tyagarajar College of Engineering, Madurai. And he has obtained his PhD in Industrial Engineering from Anna University in the year 2015. He is having a total of 11 years of teaching experience in various cadres. Currently, he is working as Associate Professor at Manakula Vinayagar Institute of Technology, Pondicherry. He has published over 40 papers in reputed international and national journals, and also presented many papers in international conferences also. He has published books on quality management, process planning and cost estimation, managerial economics, and computer integrated manufacturing, automation for excellence, etc. And he has organized 20 plus workshops and guest lectures on recent technological advances in the area of industrial engineering. He is a peer reviewer and editorial board member for various reputed international journals also. And he is a life member of Indian Institute of Industrial Engineering, Mumbai, IANG USA, and Teaching and Education Research Association, Eurasia Research. He is proficient in softwares such as design for assembly, AutoCAD, Robotics, etc. He has guided various academic projects for UG and PG students. He is regularly applying for projects, a seminar grant, or even FDP, STTPS under various schemes of DST, CSIR, NSNTM, and ASCT, etc. He has carried out a novelty research on work titled Comparison of Jute and Sisal Fiber Reinforcement Composites using Crust PCB. With the support of C Intel Services, Chennai, he has actively participated in various FDPs, national and international workshops, STTPS at various institutions. He has delivered guest lectures at the institutional level and also at reputed industries on the topics related to software applications and other industrial engineering areas. And coming to today's webinar, the beautiful thing about learning is that so nobody can take it away from you. So that's why I never stop learning. So when we stop learning, then we stop growing. Learning gives creativity, and creativity leads to thinking, and thinking provides knowledge. So knowledge makes us great. So knowledge is divine. So knowledge is powerful and it should be shared. So with this quote, so today's session, so the knowledge session, whatever we have planned. So an industrial robot we have started with. This is the third session with the application of industrial robot we are doing it. An industrial robot is a robot system used for manufacturing. The typical applications of robot include boards, circuit boards, like your the welding or painting, assembly and disassembly, and pick and place robots, as well as packaging and labeling and palletizing, product inspection and testing, and all complete with a high endurance, speed and precision. So today's topic, that is robotic work cell. It is a complete system that includes the robot, controller and other peripherals, such as a part positioner and safety environment. Or simply speaking, it is a workstation which consists of at least one robot and its controller, along with the safety measures. So to determine which pre-engineered voxel design will be most the productive and cost effective for your application. So there are few different things to be considered. It might be a voxel base, that is a positioner, or else part size and weight we have to consider, and including number of stations and robot positioning, loading type which is used, and number of robots which is required. So with this brief introduction, so I wish all the participants will have a fruitful interaction with the speaker. Once again, I thank you one and all. Over to you, Shashank.
Thank you, sir. Now I request Dr. P. Shivashankaran, Associate Professor, Manakula Vinayagar Institute of Technology, Pondicherry, to start the session.
So very good morning to one and all present here. Let me introduce about myself. I am Dr. P. Shivashankaran, currently serving as Associate Professor in the Department of Mechanical Engineering, Manakula Vinayagar Institute of Technology, Pondicherry. So today we are in the session number 3. So we are going to discuss about the details of robotic workstation, different types of cellular layout. What are the various schemes of cellular layout in a robotic workstation? And what are the challenges that are involved when the serial number of robots are doing some kind of productive operation inside the work cell or workstation? And safety point of view, how we can able to protect the human, the casualties away from the automated the workstation. So these are some of the things we are going to see in session number 3. And before going to start with the session number 3, so let me have a preview about session 1 and 2 in short, not less than 5 seconds. So in session 1, we have started about the different types of the parts of the robot and what are the various programming schemes like teach content programming, online, offline programming modes. Using motion elements, how we can able to control the different the movement and the positioning of the part. Then in session 2, we moved over to the material handling operations, how the robots are productively utilized for various material handling operations like job loading, job unloading, then painting operation, assembly, disassembly operation. Then what are the specification of different material handling robot? So and some few case studies we have discussed in the last session number 2. So now in session number 3, now we are going to see about the workstation details of the robotic mission. And these are the agenda, the proposed agenda for the today's workshop. So first let us have the pre-introduction about what do you mean by a work cell, then how to use the robotics in work cell. Probably next session, the future session number 4, I'm going to show you a software a simulation demo, RoboDK solver. So how we can able to accommodate the different arm movement of the robotic mission within a confined the work cell, the space. So that is going to be like a practical case study in the future, the session number 4. Right. So today we will see the basics, fundamentals of the robot cellular layout, then different types of multiple robot, concept of multiple robot and machine interface, Then what are the basic consideration to be followed strictly in work cell design? Then what do you mean by an interlocking, error detection, and automatic error recovery, the problem? Then the next thing we are going to discuss about how will you analyze the cycle time in the robotic operation. So these are the different the background theme for the today's the workshop. Now let us get into the topic directly. So first, let us generalize the concept meaning. So what do you mean by a work cell? Any factory, any manufacturing, the process-oriented industry will have their own dedicated fixed work cell unit. The work cell comprises of productive machine tools and a lot of other the sub accessories that are involved inside the layout. The main primary, the motto of the constructing a work cell, a productive work cell, that depends upon how you are going to organize the different type of production operation in order to minimize the cycle time constraint by speeding up the process flow, right? So by eliminating the wastage. So this is the primary objective of the work cell design. So we want to reduce the human ergonomic discomfort. At the same time, we want to improve through automation strategy. So what are the possible way to eliminate the defects or wastage by ensuring 0% defect, right? So now let us go to the next level of discussion. What do you mean by use of robotics in work cell? So as as Dr. Ramachandra CG told that in the preface of the program, so the work cell, automatic work cell, unmanned workstation will have at least one or few couple of robotic mission inside the closed space area, along with its additional control mechanisms. So to ensure the 100% safety by reducing 0% accident. Okay, so in unmanned work cell, so the human there will be entry restriction for the human casualties. So you can see in the picture here there is some sort of fencing or shield, and a barrier is provided. So the robot will not allow the human casualties to enter into the automatic workstation. So this kind of safety regulation act, so we can provide to safeguard the persons from the drastic accidents or injuries. So what are the general next thing we are going to see about what are the general things to be considered before designing a work cell. So here comes the further the continuation. The following details are listed here. So first thing, we need to identify what kind of production job you are going to carry on, and based on that, the work cell layout has to be planned through simulation software, and then we need to go for the real the layout of the work cell environment. Just for example, if you want to go for a product type layout, then you're supposed to construct a serial transfer, a single line linear workstation, okay, like a long conveyor, right? So in that we can decide how many number of the robotic mission has to be installed in every the workstation, which adapts the product type layout function. Then first, next one, determine the overall, the outline, the operation, how you are going to perform. That is where you are going to feed in the part, the work material, and how the work material is going to be transformed into a component or a finished item at the other end of the work cell. That is the exit. There should be some entry and exit point in the work cell station. Okay, in routing the material. The next thing, choosing the appropriate robot with the right application to do the job. Probably in the second, the session, the last session, we have seen a lot of application of material handling robots like Motoman, HP, ABB robot and KUKA robot. So these are the general purpose the machines that are used for lifting the pallet, loading the materials into the machine, like that. So we need to find out the corresponding the application for which you are going to install the n number of robots to do the right application. Then at last, design the layout by considering the efficiency and also the rapidness in completing the task. So these are the basic things. So we want to consider before going to design a work cell construction in the factory environment. So this is must for the system designer, the layout planner. So in order to undergo the challenges or any hurdles. So if it is any, then we want to correct according to the comfort of the operation by avoiding the obstacles. Then the next thing, what are the advantages, the benefits of developing a small nuclear the work cell in robotics? The first, the main benefit, so we can able to increase the efficiency and product the throughput. How? So here the robot work cells are made to allow the robot with the fullest efficiency, 100% capacity and high speed. So there are certain safety regulations to be followed in the work area, so that there must be a limiting criteria in order to control the speed of the robot in the presence of a human being. For example, if a human casualty standing nearby an automated workstation, so there must be some speed restriction or control limit. So in such a way, we want to prepare some upgradation in the software, the program for controlling the robotic machine. So by identifying the obstacle object, whether it is a human or a non-human thing, okay? So to identify the barriers. Then the next thing, the layout regarding the work cell design layout should be highly customized, simple, easy to understand the various the workflow, the process, so that the work can be completed more quickly. So we can able to maximize the throughput, the output of the product in terms of more number of production volume. The next advantage, the benefits, the work cell in robotics, in that we are going to discuss about the increased safety assurance to the human operator. So keeping the operator safe is considered to be the utmost importance in unmanned workstation. Since it is known from the general fact that so the machines like the robots are highly powerful, so they may cause a serious injury if that has not been handled correctly. So we want to provide a safety guard or a shield or a divider line, so that the human will be prevented in entering into the robotic workstation. Or we have to keep some scanners or emergency stopping devices. The next one, so what are the things we want to accomplish for an automated the robotics considering the work cell design? So the work cell is created normally for a few purposes. So one among the primary reason to protect the human worker from the unwanted the threats. So the automated systems are constructed so in such a way that so heavy components always will move at a very high speed. So sometimes that may injure the neighboring human personnel, or it may hit or collide the human personnel. So we have to stop those kind of things, and also lifting the heavy material object from the ground, from the floor level. So we want to keep some safety alarm or some kind of a sensor alerting message or a signal in order to caution the human worker. So in that way, we can able to productively accomplish the robotic work cell. And now next comes the main important the theme of today's workshop. So different types of the work cell layout in the robotic sciences. So we are going to see about three different the types of work cell layout inside the plant that is available in the current existence according to the literature survey. So the first one is the robot-centered work cell. The second one, later we are going to discuss about inline robot work cell, that is called as a product layout, inline layout, serial transfer line layout system. The last one is the mobile robot work cell unit. So these are the various the schemes of the plant layout, the design. Now we are going to discuss one after the other. So now let us start with the first one, the robot-centered work cell. So this is the systematic the illustration, the concept illustration that has been presented in the figure. So you can see the robot is placed in the center area in the mid position, surrounded by a pair of the productive machine tools, right? And storage bins are located for picking and storing the objects on either side. So here we want to describe how the robot-centered the work cell functions. So according to this layout, the machine has got a high usage of space, high utilized space. So for example, we can say the conveyor, the method of part delivery using the robot, we can use a conveyor or a part feeder mechanism. Okay, so we can equip a single robot to do the multiple operation. That is one or more the multiple operation, not more than two machines by equipping a single robot, right? So these are the speciality of the robot-centered work cell. The next one is inline robot work cell. Here we can have a long conveyor which is equivalent to infinite length. For example, more than 1,500 meter, right? So in this case of layout type, we must have a multiple robot we call as a collaborative robotic mission. So two or three or multiple robots can be joined together to do the workflow, the process. You can say welding line, automobile assembly shop. So these are some of the standard the examples that can be used for defining what you mean by an inline robot work cell, right? So normally it is used for the sequence dependent the assembly operation, right? I can give a simple example here. It is one of the best example for a sequence dependent automobile, the car assembly unit. So the assembly, the part of the automobile will be ordered as per the sequential, the product nature, such as that one or more than one robot will do the part integration, the process, right? So this is the way in which the inline, the work cell, the concept applicable for the robotics and automation. And under the category of inline, the robot work cell, what are the different the schemes that are available? Intermittent transfer, continuous transfer, and non-synchronous the transfer. Okay, so we will see all those available the subcategories under inline layout. So under inline layout, first one, we are going to discuss about intermittent the transfer cellular layout. So what do you mean by the basic term, the intermittent? So it is not like the continuous operation. So here, every time, each and every time, there will be some interference of a robotic arm manipulator in between the production operation. For example, if the robot arm should go and pick the part from the conveyor for a packing application, so this arm will move forward and it will carry the moving part which is flowing over the conveyor. So this is called as intermittent. Okay, so it is not a continuous job operation, right? Sometimes inspection also we can able to perform intermittently after every partial completion of the production operation in each stage, level by level. The main key advantage here in this intermittent operation, so the robot will keep remember the origin, the fixed position, so where it has started its function, the operation. Accordingly, it will try to orient to the next node or next path. So during the entire the work cycle. So the next one, the second one is the continuous transfer, the work cell layout. So what is the speciality of the continuous the work cell layout? So here the jobs are made to flow continuously around the circular, the round table, the rotating table, and the robotic machine will be mounted in the center of the rotary table. So here the jobs will not be disturbed. So it will be flowing continuously. So whereas the robotic arm will monitor with the help of the sensor unit, so that will monitor the flow, the track of the movement. So whether the jobs are available with the correct the specification dimensions or not. If any poor or non-defect, if any defective products are present in the continuous flow path, so that will be rejected by through error rectification, automatic error rectification, right? So now last one is the non-synchronous work cell layout. Here there is no such kind of the standard the time rule or any logic. So the arrival time of the part will be considered to be irregular in nature. So accordingly, the robot has to indicate through sensor. So in order to identify the difference in the part arrival time and also the departure time in order to execute the work cycle. Then the last one is, as per the specification of the work cell design, the mobile robot work cell. It is like a mini the transport or a logistics. This kind of this layout, the cellular layout functions. Here the robot is considered to be like a moving one, like a four-wheel drive, it will function. Whereas in the earlier times, the arm only will be moving from one end to the other end, whereas the entire body will be resting stationary in a particular the fixed location, right? So this is called as a mobile robot navigation. So here it can able to move at various direction to different location in order to identify whether the parts are assigned in the mission or not. Okay, for scheduling and sequencing application, we can use effectively the mobile robot work cell type. So the next, after undergoing this basic the classification of the plant layout design in robotic work cell, now let us see the concepts on the physical interference of robot and machine interference. So what is the difference between these two concepts? So first let us go with the physical interference of robot. Here, the work volume is nothing but the space, the confined space allocated to the robotic machine inside the cell. Sometimes that may undergo overlapping or some sign threads will be indicated by like a collision. So we want to prevent the overlapping operation. If two robots are in the same work cell, so we have to provide a safety measure between two automatic machines by incorporating a sensor in the robotic arm manipulator, such that if one robot nearing to the next one, neighboring robot, it will detect with the help of the sensor, such that the positioning of the arm movement and also the speed that will be controlled, such that we can able to reduce the collision or hitting between the two robotic machines. So we can also avoid the overlapping of parts by providing a temporary barrier between the two machines, right? So the next one is the machine interference. So here when two or more, the multiple the production machines are being serviced, by one single robot. Here, the cycle time constraint are considered to be the main that will add a main impact in terms of percentage of idle time. So, however, the production machine tools are timed in such a way that experiencing the difference in the idle time between the multiple parallel mission if only one robot is available in the station. So let us take, if one mission is serviced by the robot, the next mission will be remaining idle until and unless the particular job is getting over from the previous mission. So here we can able to apply some innovative methods to reduce the total idle time by bringing additional robots, or we can provide a dual gripper by having a single robotic arm so that it can able to do the parallel the task concurrently by reducing the percentage of the idleness in the job operation. What are the next thing we are going to discuss about the further continuation in the work cell design? What are the modifications we can provide in the work cell design? The first thing, part positioning and orientation. And next one, part identification according to the physical geometry. Then protection of robot from its external environment. Then control of work cell and safety aspects. Let us see one after the other what are the general modifications we can able to perform in the robotic work cell design. The first one, part positioning and orientation. Here, when the work part are being delivered, fed into the work cell, it has to identify the precise pickup, the position or location when it is moving along the conveyor. So the robot has to identify what is the primary, the pickup area from which the part has to be located with its gripper, exactly using the sensor and other control system. The part should be kept in a particular the position so that the arm should be very flexible enough to grasp for a robotic mission. Okay, so the way in which they're designing the work cell, so that will try to improve the easy handling of the work part, and also it can able to change the arm direction, okay, right, based on the work volume size. The next one, part identification problem. The second modification we can suggest is that the part identification problem. So using image recognition technique or optical the characteristic recognition method, so we can able to identify the physical shape or the entire the geometry of the part, or with the help of the electronic tagging method like RFID. Okay, so we can identify where the part is exactly located, and that instruction will be given to the arm manipulator of the robot as a basic information. So accordingly, the further decision will be carried out by the machine in doing the work cycle operation. The next one is how to protect a robotic machine from the surrounding environment. Certain application areas like spray painting or metalworking jobs, heavy metalworking, hot metalworking jobs, abrasive applications. Okay, so in these applications, we have to provide some sleeves or overhead guarding mechanisms. Okay, so to prevent the adverse outcome effect from the surrounding atmosphere. The next one, control of the work cell. So the certain activities should not cross beyond the boundary of the work cell. So if you plan 4 or 6 kind of a production activity, so that has to be carried out safely within the work cell. The arm should not reach outside the work cell, the robotic arm. So in such a way, we want to design the space, the layout comfortably to accommodate, to fit in the robotic machine inside the cellular space, layout space. The last one is the human safety, right? So this I have already told you in the previous, the introduction, the part. So the humans must be educated well. If any work automation task is going on, so they should not go nearby the particular the hazardous area. So now let us discuss about different controlling strategies in the work cell design, the robotic work cell design. So one is sequence control. We are going to discuss. The next second one is the operator interface control. And the last one is safety monitoring, right? So these are the three different schemes we are going to discuss in the work cell control. The first one we will see about what is sequential based control. So here in sequential control, the robot will try to regulate what are all the various sequence of activities that are to be ordered as per the process sequence or operation sequence. And next one, how to control the simultaneous activities by equipping different kind of robotic mission. And also we want to decide when to start an activity and stop depending on the number of events regularly that is happening in the shop floor. So for an example, for a sequence control, here they have given two examples. So how to plan systematically the sequence of activities. At the same time, if the idle time, the percentage of idle time is maximum, that may try to lose the productivity of the job completion. So what are all the wastage activity that can be avoided? So these are the two examples. Now we are going to discuss in much more simpler way. Step one, operation one. So first thing, the robot arm tries to pick up the work part from the moving conveyor. Okay, by that time the production machine tool is idle. Okay, that is before loading condition. Now the robot loads the part into the fixture at the machining center. Right. Next step number three, the machining center begins auto machining. So it does the manufacturing process without the consultation of the human operator. After completing auto machining, the robot arm goes nearer to the work part and it tries to unload the machine. That is, unload the part from the machine. And finally, the arm moves back to the original pickup point. So these are the 5 steps. So here there is only single gripper, okay, available with a single arm. But if I want to optimize the percentage of idle time by reducing any one of the process steps, by keeping 3 or 4 minimum number of process steps, I can go for double gripper mechanism. Okay, I can providing a single arm. So on the wrist end of the arm, I can provide a double gripper. So here let us see a robot picks up the work part using the first gripper from the conveyor at a known fixed location, right? Then the next one, it moves the double gripper into ready position in front of the machining center. After completing the auto machining, the robot tries to unload the finished part from the machine fixture with the help of the second gripper and loads the raw material into the fixture with the help of the first gripper. So this is the way in which we can reduce the cycle time and also the probability of idleness present in the work cell. So finally, it moves back to the original position. So here the number of the programmed steps carried out is only 4. So, right. So instead of having a single gripper, we can provide a 2 multiple gripper in the same arm, such that we can able to save the time and also we can able to maximize the process efficiency. Then next, under work cell control, operator interface. So here the operator interface is mainly used to program the robot or to modify, update the program. Okay, so during the work cycle, no human operators are not supposed to update any additional programs into the robot memory to do the new task. So entirely that will pollute the program memory of the robot, right? So we should not do such things. For example, if your robot is well trained into the painting operation, according to that, we need to feed the software related work additional the command to the main memory of the robot system. Okay, so you should not confuse or pollute a robotic machine by adding a new set of the fundamental subroutines into the main memory. Then the next one, the safety monitoring system. So here we want to provide some kind of buzzer sound or safety alarm signals in order to caution any obstacles, moving obstacles, that may be a forklift truck or a man, physical man, so whatever may be, right? Even a failure is going to happen, a machine is going to break down, or any failure is going to happen. So that should be given with automatic signal indication, right? So next thing here we are going to discuss about the concept of error detection and recovery, right? So here some kind of a malware or hardware corruptions sometimes happens if it is not updated or maintained properly. So due to the unskilled the human, the programmed assistants. So first of all, in order to control the accuracy of the automated robotic machine, so the human personnel are to be trained, programmers, the system programmers are to be trained to rectify the different the hardware, the corrections that are frequently occurring in the shop, right? So because a basic industry purpose robot does not have the capability to correct the mistake on its the own, still it requires some trained, the programmed assistants to recover all these the error functionalities. The next thing, how to detect the error. So using appropriate sensor and signal input, error can be recognized and it can be broadly measured into 3 levels: random errors, systematic errors, and illegitimate error. So random errors, let us take for example, while measuring the part size, while finding the difference between multiple the part dimension, okay, after carrying out the machining operation, if the mean value is seems to be significant, that may lead to some problems in the subsequent manufacturing process. So we need to maintain the sensors that are incorporated in the robotic machine. Okay, we want to calibrate the precision accuracy in detecting correct the measure of error. Then the next thing, systematic error. So here incorrect machine clamping, that is a job setting or a tool setting. So that may also lead to systematic error. Then illegitimate error. So here the error found in the program itself. So these are some of the things we need to take into consideration in order to perform, in order to make the robot to do the work with 100% efficiency and zero tolerance. So the last one, now we are going to discuss about the cycle time. What are the various, the cycle time analysis, the concept of cycle time analysis applicable to the different operation. First, cycle time is nothing but the time interval between each operation, starting and the finishing time. So here let us take a simple motion element. Suppose I want to make the arm to move in vertical or either in horizontal. So what is the cycle time at which the arm has positioned its direction to move in horizontal path or vertical path? Next one, sensing element. So if any object lies behind the robotic arm, so what is the time required it takes to sense the given physical appearance of the object before it is going to be grabbed in between the gripper of the robotic arm? The next one, end effector element. How close you are moving the end effector to the target location. The next one, delaying element. If there is any production delay or waiting time due to heavy queue of job parts, so what is the time taken to sort the component which is said to be finished or semi-finished material using the automated sensing system. Last, I would like to conclude today's the workshop based on the major inputs that has been given on my best of my knowledge regarding the robotic work cell. So we have seen about the different types of layout, like inline layout, then mobile robot work cell, then robot-centered work cell. Under that, we have seen various sub-schemes and also some safety aspects under each type we have seen. So with all the basic input, I conclude that the design of the robot work cell layout is mainly applicable to protect the human worker away from the workplace under high productive plant operating conditions. Efficiency of the work cell that depends upon how simple you are creating a space, a cabin for a robot to perform its planned operation with the zero risk by simplifying the space within the provided region. So with this, I thank the listeners, the active listeners, the participants, and the program in charge and program director for giving me the chance to share my view on the session 3, the importance of the robotic work cell design. So thank you, one and all present here.
Thank you, sir, for the wonderful and informative session. Now the participants can ask a question or interact with the speaker by unmuting themselves. The provision is given to you.
Yes, anyone is interested to speak with the speaker directly, you can unmute yourself and you can start asking any clarifications or any questions you can ask. The floor is open for you. Or you can put it in chat box also. We'll take the questions from the chat box also. Anything related to today's topic. Okay. If there are no questions, then we can proceed, Shashank. And Shashank, we can continue. So if there are no questions.
I request Dr. Ramchandra CD, the Managing Trustee of Sanatana Sampratishthana, to summarize today's webinar.
So at the outset, let me thank Dr. P. Sivasankaran for his presentation and more informative session. And coming to today's the webinar, so at the beginning, he has given the complete details what exactly we mean by a work cell, which is nothing but it's a logical and strategic arrangement of resources in any business environment. That is what he has told. And even work cell in robotics. So it is a workstation which maybe consists of at least one robot and its controller along with these safety measures. And then later he spoke about what are all the things to be considered before designing a work cell. So those information he has given. And various benefits or the advantages of work cell in robotics he has discussed. And the different types of voxel layouts in robotics, like robot-centered voxel is discussed, inline robot voxel, as well as mobile voxel is discussed in detail, and as well as the different types of transport systems, especially in an inline robotic cell is discussed, like intermittent transform, the continuous transform, a non-synchronous transfer. So these are the things he has discussed under that. And the multiple robots and machine interface. Under that, he has discussed what are the physical interface of robots as well as machine interface. And even he spoke about some of the modifications in work cell design and voxel controller control. We discussed about sequence control and operator interface, as well as safety monitoring, as well as he has discussed the error detection and recovery also about this. And at the end, he spoke about the robot cycle time analysis. So main elements of this, like motion elements, they are discussed, sensing elements, end effector elements, as well as delay elements. So these are all some of the key the points he has highlighted, and he has given more information about it. And at the end of the session, he has concluded nicely. So robot voxel live design is mainly used to protect the human workers away from robots, and by using various fencing or shielding within the plant operating conditions. So this is what he has concluded, as well as the efficient. He also quoted that the efficient work cell improves the simplicity in handling the work operations at more of reduced risk, and even by simplifying the available space within the region. So this is the highlights of today's the webinar. So I thank even all the participants for joining us and making this the webinar a success. So over to you, Shashank.
Thank you, sir. Gratitude is the essence of humanity. I thank Dr. P. Shivashankaran, Associate Professor, Manakula Vinayagar Institute of Technology, Pondicherry, for accepting our request to be the resource person of today's webinar, and also for delivering a very informative session. Thank you, sir. I thank Dr. Ramachandra CG, the Managing Trustee, Sanatana Research and Training Institute, a unit of Sanatana Sampratishthana, Mysuru, and Dr. Raghavendra Prasad, MD, President, and Shri Dinesh Kumar DK, Secretary, Rotary Club of Mysore West, for their involvement in organizing this webinar. I also thank Shri Lokesh CG, the President, Dr. Shantaraj Aras, and Srimati Bhagya Gopal, the Board of Trustees, Sanatana Sampratishthana, for their support extended in organizing this webinar. Finally, I thank all the participants for your support and active participation in this webinar. Thank you, one and all.